Oh, sorry, I'm muted. Thanks for tuning in to the Cloud Native FM podcast. You are listening to the host, Saim, the co founder of Cloud Native Islamabad community and the organizer of the very first case study Pakistan. Good morning, good evening, good afternoon, regardless of where you are or watching or listening to this show. A very, very warm welcome to the show, a show which brings in the latest and greatest news from the CNCF ecosystem to help you keep up to speed with what's going on, where you need to be focused on more, and where you meet the brave mind and awesome community members, co-founder of the most watched open source project. And today is May 24th. I'm really excited. After a long pause, I will be back again. The Jim is back again on the show. Thank you very much, Jim, once again for being on the show today.
Thank you, Sam. Pleasure to be here.
Yes, absolutely. And today we're starting off a very, very important topic, and I think it deserves a conversation because we recently announced, I think in Kubernetes 1.26, Kubernetes validating admission policies is now being introduced and a kind of a standard to implement how to write policies with the common expression languages. I will learn from more from you, but let's first might be some of the audience completely new on this podcast for listening to us. What do you think, like how the Kubernetes API server actually interact with the inner components of the Kubernetes and how the state maintain that help us understand the topic in a good way? So can you briefly explain how the Kubernetes API structure work?
Sure. Yeah, so Kubernetes being a modern application, it is very much API driven. So all Kubernetes components, or when users or other systems interact with Kubernetes, they always go through the Kubernetes API. So even for example, even if you're kind of doing an exec into a pod, there is an API server request for that, which will be triggered, and that API server request will then get processed. It goes through different phases of execution. The first phase is authentication and authorization, right? So you want to know who the request is from. Are they allowed to perform the action that they want to, perform? And this is where, like your diagram is showing, RBAC configurations come into play, and RBAC, your RBAC rules will be imposed um, with Kubernetes itself. The next phase is something very interesting, right? And that's called admission controls. And what happens here in admission controls is Kubernetes runs a different built-in admission controllers, which are configured in the API server itself. Now, some of these admission controllers may run directly in the API server, whereas other admission controllers will run, as external systems, which could be, sometimes is known as, dynamic admission control, or even, webhook admission webhooks, which can be configured, right? So an example of an inline admission controller is, you could configure in the API server. You could say something like image pull policy always, right? Which basically will say that every time there's a pod created, or there's a pod modified by the API server, to set the image pull policy to always instead of if not present. Now this will happen directly in the API server. So it's very, it's of course efficient. It happens inline, and there's nothing else, no other component required. Now, one type of this, like I mentioned, is if you want to call an external system to do other more complex checks, or more complex mutations, or trigger workflows, then you have the option in Kubernetes to configure, a webhook based admission controller, which is what policy engines like Kyverno, Gatekeeper, OPA, those policy engines will leverage to be able to receive API requests from the API server, and to be able to respond to that with an allow or deny with the right reason for it, or like in Kyverno's case, to trigger background workflows other things which might want to be processed when that API request is handled, right? So the really elegant thing here is that each phase of this is extensible. Kubernetes is designed for that extensibility and to be able to plug in these components and to perform more operations as part of the control plane, which is what policy engines leverage. So that's a little bit of background on the API server and how an API request works. And it's something which is extremely interesting to understand and to see. And if you kind of look on your systems and if you look for validating and mutating webhook configurations, you will see that there could be based on the type of add-ons you're running, there could be multiple admission controllers configured on your system.
Yes, absolutely. I think that story is really relevant to the audience because in order to understand what the WAP does and why actually WAP exists, I think you need to be a broader understanding of how the different pieces work within the Kubernetes when you're interacting with the API server. So I think for the mutation webhook, we know that Kyverno policy engine is actually mutate some of the resources. So basically, what will happen, you have a controller running inside of the Kubernetes, and you give a webhook request to the controller in order to, let's say, mutate resources according to the need. Let's say you doesn't specify CPU and memory in the Kubernetes manifest. That mutation actually does it for you. Some people, this is a debate like, do you like mutation? Some prefer not because they think they need to understand who does what, like who actually changed the manifest. So that's a separate debate. We can talk more about on that as well. But the next phase is schema validation, where tools like Dartree, specifically things like how the YAML that's specified or actually given to the Kubernetes is cluster API server, are they are validated in terms of the text syntax versioning as well. And the last piece where we spend a lot of time today is the validation admission controller, where the policies is actually worked. Like if I want to allow only signed container images to be allowed on the Kubernetes cluster, validation policies actually help those. And Kyverno, what we're talking about today, is integrated with Project 6 store tooling to help you sign the images, or you can write policies that can be denied or accepted. And then you have CPU memory defined images should be pulled from, let's say, not from Docker Hub, from there, rather ECR or ACR or the GCR. And you can combine policies with monitoring tool. So that is validation is actually the way it's behave. I think it's got us a magic. Like if you given a request to the API server to have a deployment ready, that's where your validation is actually a real magic.
Right.
That is actually help you deny or accept the request. So with that in mind, the Kubernetes community, the Kubernetes maintainer and the authors have seen every policy engine as of today has their own language of specifying the policies. In Kyverno, they are using native Kubernetes language. You don't need to learn any new language. You just need to have a regular expression understanding, and you can write policies that can be actually deployed to the cluster. In Rago space, they use an open policy agent or the gatekeeper. They use a Rago language. You write policy in a different language and then deploy it on the cluster. And they see a community, there's a no standard exist, and WAP is actually becoming part of building a standard. And Jim will know us more about this standard as well in a minute. But according to my understanding, it's using the cell, the common expression language. So based on your understanding, Jim, can you elaborate more on this topic, how
Sure.
this approach is different from the third party tooling?
Yeah, so maybe just stepping back and first, discussing quickly the need for policies itself, right? So, at a very high level, policies are Kubernetes configurations that manage other Kubernetes configurations or runtime behaviors, right? So, that's important to keep in mind. And because Kubernetes tends to be a very complex system with different roles. It's extremely important that you have policy management from day zero, because different developers, operators, security teams all need to interact in Kubernetes. They all need different pieces of data, and the policy becomes a digital contract across these roles, right? So it's extremely important to think about that carefully, and to scale Kubernetes, to manage Kubernetes efficiently, even for things like FinOps and cost management, policies become the right way to do that. Now, you could implement policy. There are, of course, like native policies in the API server, with built-in objects like network policy, or even things like limit range and quotas and those are all just API objects in Kubernetes itself. Then there's, like we talked about, admission controllers, which can be turned on and off in the API server. Then there's, mutating and validating webhooks, which is what, different policy engines like Kyverno, as well as, Gatekeeper have leveraged. And then now there's, the validating admission policy. So if you kind of look at the evolution of, policy engines, um, Open Policy Agent was the first CNCF project which brought policy to Kubernetes. And all the use case was very clear, but Open Policy Agent, started with it uses Rego underneath as the language, like you mentioned, which imposes a learning curve, which imposes a challenge. There could be some efficiency issues at scale if you have to operate on a cache data set, things like that, which becomes challenging for Kubernetes admins who understand Kubernetes but may not want to now spend all the time effort to maintain, develop, and manage policies in an external language, right? Which is a declarative DSL, based on JSON processing, but really doesn't have any knowledge of Kubernetes. And Gatekeeper tries to solve some of those problems, and it does a fairly good job in some areas, but still there's a learning curve. Ultimately, you need to know Rego, right? So Kyverno solved that problem by saying, look, why not make Kubernetes policies native to Kubernetes, do everything as custom resources? So really, the focus on Kyverno was never about a language, right? And we had looked at several languages, but it's saying make it as easy as possible for Kubernetes admins to write policies and to manage policies, right? Because one thing which is important to understand, writing a policy is not just enough. If it's kind of like people say, if a tree falls in a forest, did it actually happen, right? Because if you write a policy and deploy it, you need to know the results of the policy. The right people on your team need to know the results of the policy. They might want to request a policy exception. So there's all these workflows around policy management. You might need approvals for certain policies or for certain policy exceptions. All of that has to be thought through if you want to adopt a policy based approach to operations and management. So as we kind of started with Kyverno, we said, look, let's make policy management native to Kubernetes. And that's not just about writing the policy, that's step one, but also more importantly about, doing all of these other operations and workflows around policies. And we're not going to start with a specific language. We're going to say, look, like Kyverno today uses JamesPath, it uses X5 or internally you can use Open API v3 schema, other things as well, to manage Kubernetes policies. And we've always been open to, as other languages and other things get standardized, to be able to adopt those and incorporate those, right? So the next evolution of this, and Joe Betts, who's one of the lead authors of validating admission policies, the next evolution of this, was, okay, how do we bring policy further down into Kubernetes and make it now, built into the API server as much as possible? So that's where Joe and team proposed, validating admission policy, and we had, chatted about this maybe about almost 2 years ago, right? And I think it's a fantastic step forward for the community, right? Because now Kubernetes, the API server, truly becomes programmable. and policy becomes more and more native to Kubernetes, which is the end goal of projects like Kyverno, right? It's not so much as to, say which policy language is better, but how do we make policy easier or more native to Kubernetes, and and build these workflows around policy management, which enterprise teams will want. So with validating admission policies, the language chosen is, like you said, common expressions language, which has been used in a few other areas. It's not a very widely known language, but it's fairly capable. It does basic checks, just like with Kyverno you can do. And at that time we had shared all of the different customizations we had to do with JamesPath, the types of logic to handle. So looking at those examples, I think the Kubernetes cell library is also getting evolved to be able to handle some of these type of more complex things, which today it may not be able to do, right? So to be able to compare, like for example, things like Kyverno can do nested for each checks, right? So those type of things will not be easily possible in cell, but over time those things will get improved, and we're certainly looking forward to seeing that evolution. And the obvious question then is, what does it mean for Kyverno if somebody has adopted Kyverno? Now should they kind of switch to something like validating admission policies, and when should they choose one or the other, right? So first of all, one thing to think about is today, in Kubernetes, you have these validating admission policies. There is some discussion to, in the future, maybe even do some simple mutating admission policies directly at the API server, but that'll take some time to evolve and figure out, how to proceed there. But the idea is to make this available again as natively as possible, and then Kyverno, as well as, I'm sure other policy engines like Gatekeeper, will adopt what's native in Kubernetes if their focus is Kubernetes, which is certainly true for Kyverno. And I'll share some examples of work that we're already doing, which has been started, and how Kyverno will evolve to embrace, validating admission policies, cell, and just make that native, right? So the idea is, if you are writing a policy in Kyverno, it may run at the API server level, or it could run as a webhook level, and users shouldn't really care, right? Users should worry about the logic that they want to write in the policy, and Kyverno will handle that automatically for them if it needs to be run as a validating admission policy, or if it should be run in a webhook because it's a more complex check that requires external data, or maybe it's a mutating or generating policy which cannot be run at the API server, or like the example you showed with software supply chain security, if you want to do things like check image signature, stuff like that, which will not happen in the API server, Kyverno will then run as a webhook. So the idea is to make this very transparent for the users, and to be able to also leverage other things for policy management, right? Like reporting, exceptions, running policies in a CI/CD pipeline. That sort of tooling around policy management is where Kyverno, we believe, shines and offers the best user experience overall for Kubernetes administrators, developers, as well as security teams.
Yes, absolutely, absolutely. So I have one question, like I think might people currently have, like we see in the diagram where we actually let people know there is a flow of
Mhm.
requests being actually given to API server, and how is actually respond to that request and eventually propagated that response into the etcd. And before the state get persisted, there are a bunch of activities being happening. Let's say if we adopt VAP, do you
Mhm.
think this architecture change? Because one of the things people like to say, having a mutation webhook or validation webhook can cause some of the harms. Like you always try to connect with the controller that running
Mhm.
behind the scene, and then request that forwarding to the controller, and controller do the heavy lifting up what you actually need currently status. So currently might be there's two questions I believe people have in mind. Number one, they think I number one is this is the language, the standard. Can we expect to see a standard? The cell become the standard in the policy world in Kubernetes. And all the implementers like Kyverno, OPA, or bunch of other, we name it, can actually adopt to that standard and do the same job they already been doing, but having a common language for everyone to consume and use, meaning admin, platform admin, or the developer, or anybody is actually interacting with the cluster. They have a common language, irrespective of the third party tool they are using. So, is this happening? Do you see the current wave is?
Yeah, so let me answer the second question first, and then we'll go back to the architecture and what difference it makes. Whether you execute in a separate webhook based admission controller versus inline, right? So certainly, because Cell is being adopted in Kubernetes, any policy engine that works on Kubernetes will need to acknowledge that and will need to deal with policies if they want to process policies or manage policy results, etc., within Kubernetes itself. So I think that I'm not sure if it will replace every other policy language, but what you're likely to see, at least for some foreseeable future, is that more and more you will have multi-language policy tools, right? So Kyverno, of course, already has a policy structure, like does OPA with Rego and constraints and other things that Gatekeeper offers. So those will continue, but they will also add support for Cell, which will be complementary to what happens in Kubernetes. Now, more and more as Cell kind of matures and as the Kubernetes Cell library. So by the way, we should separate the language from other functions and extensions to it, right? Because just like with in Kyverno, we have JamesPath, which is extremely powerful, fast, and efficient for JSON processing, and can be used in memory for large, JSON data sets. But even with Cell, but with just completing on the JamesPath part with Kyverno, we have written several filters. Filter is like a function in the JamesPath world, which will extend JamesPath to do things like decoding an X509 certificate, right? So things like that, which are not language specific, but are required extensions to do policy logic. So same thing with Cell. There's a language which is fairly well defined, has a grammar and things like that, but then there are several extensions to Cell which the Kubernetes community is developing to be able to more efficiently and process more complex things on JSON data, again, the admission request in this case, which is the main focus, right? So I think those two things need to be separated, the language from these functions and helpers that you build around it. So with that said, so I think as that matures and as more and more processing can be done with Cell, certainly I expect policy languages which focus on Kubernetes to start adopting that and to be able to process, cell-based process policies as well. And think about like today, if you're in the, like a third party, let's say you're creating Istio or your some other add-on in Kubernetes, right? So at that point, if you want some policy checks as part of your add-on, today the problem was you had to pick either Rego, or you had to pick and go with something like OPA Gatekeeper, or you would have to pick Kyverno's way of doing policies and go with something like Kyverno. But now, of course, it would make sense for those add-ons to say wherever they can just use what's built in into Kubernetes and write those policies with as validating admission policies using Cell. So that will certainly be the most popular way for any of these add-ons who want to incorporate policies as part of their, system itself. So now with these other like policy engines like Kyverno or Gatekeeper, they will have to process not just. So by the way, policies are not just to be run at admission control, right? Policies, Kyverno also runs policies periodically with background scans, because keep in mind you might have let's say you have a version 1 of a policy you introduce into that your production cluster. Your cluster already has workloads which are running in it, right? So those have already passed the admission control. You still need to apply policy to those workloads, which validating admission policy doesn't do. So you're going to need a policy engine like Kyverno or OPA Gatekeeper to do those kind of functions. And then secondly, the best practice is to actually apply policies in your CI/CD pipeline. So how do you do that with validating admission policies, right? You can't wait till somebody tries to deploy this into your cluster. So Kyverno already has CLI support for validating admission policy, which is already available in our main, and will be part of release 1.11. And and I'm sure other policy engines will add similar functionality and features as well. So that's kind of how we see will, going back to your question of will cell become the standard? I think over time, yes, there is that potential. And more, at least in the Kubernetes community, we will see that being leveraged, and that will influence other things built on top of Kubernetes as well.
Yes, absolutely, absolutely. And now, as we talk about how this work, like how the validation admission policies
Hmm.
work as of today, we see a similar structure like Kyverno of you constructing the policies. Like if you look at the API version, we have admission, validation admission policy, and we have admission, validating admission policy binding. And
Yep.
then you below, if you look at the how these two different aspects work, I think the number one is to actually declare what are the different resources you want to apply a policy on. In this case, from the Kubernetes example, from the validation policies,
Hmm.
is you actually using a resource called deployment, and you can actually looking for the operation called create and update. And the validate describe the abstract, and that is similar, I guess, how the things work. But they've introduced a new concept called binding, and that is where the cell is written. There's expression called cell, and now if the people is actually watching us and listening to us, they have few questions. I believe I have those questions as well. Number one is people think like for the policy engine, they're not intelligent enough as of today, most of them. That actually might, let's say you have a deployment, under deployment you have replicas and you have a pod. And if you define a policy for the pod, so then the policy engine ignored the hierarchy,
Hmm.
because Kubernetes is a hierarchical structure. And remember, in this policy, all we're saying is you need to have less than 5 replicas or equal to 5 replicas. If you go beyond that, this policy will be denied and you don't be able to create deployment. But let's say this deployment is a part of vertical auto scaling group, and
Hmm.
those, let's say Kada or anything else, is actually integrating, or actually they create 100 replicas. For that,
Right.
you doesn't able to do anything else. And might be if they actually the validation admission policy detect those, they end up in a loop. They're saying that you are not allowed to do it, and they keep on scaling the pod. And then the policy admission coming in, what's happening here? Why my things are not working as expectedly? So the question people might raise here, we know this is an alpha, there might be more graduation and more feature adoption come to it.
Hmm.
But in terms of the bigger question, like, do VAP able to understand the hierarchy of Kubernetes? That is very important to understand if the
Right.
expression or approach.
Yeah, so there's two things there, right? So one is with validating admission policies, does it understand like things like pods and pod controllers? So if you have a deployment managing pods, should the policy be applied at the deployment level or at the pod level, right? In Kyverno, as you probably know, we have an auto-gen feature, which since our first release, where we automatically generate controller level policies if you write policies at the pod level, because it's intelligent enough to know that hierarchy and to understand that. Now with validating admission policies, that you would have to write two separate policies, but again, with Kyverno 1.11, the plan is if you're using Kyverno to be able to manage validating admission policies, Kyverno will automate that for you, so you don't have to worry about these type of hierarchy and things like that. Kyverno will automatically create that and manage validating admission policies internally itself. But the other question you asked is also very interesting. Is there could be scenarios where you need to look up data from external systems to make a decision, right? So, say for example, today validating admission policies operate on an API request. In the API request, if it's a create, you have the new object that's being created, and you have some information about the user that's trying to create, or the role, or things that are trying to create that. But that's it. Your policy decision is limited to that information, right? And you have to inspect that data and say, should I allow or deny this operation, or should I mutate it if you're doing a mutating webhook, right? But a lot of times policies require information from other systems. Like you might want to look up a config map. You might want to call some external server, or some other service to make a decision and get data from that service. Like maybe it's Prometheus, maybe it's SCADA, maybe it's inspecting other things like, hey, does this namespace that I'm trying to create this in, I want to query it and see if there's an annotation on the namespace, right? Things like that you might want to do, which you will not be able to do in validating admission policies because it's limited to operate. The decision has to be made on the data set available at that point, which is just the API request, right? So that's something to keep in mind, where, if you're using a webhook based admission controller, you have that flexibility to retrieve cache data, like just, for image signing and verification. You have to call an OCI, registry to be able to get information for the image which is trying to be deployed. That is not something that the API server, I don't envision any future where the API server would make these type of external calls, right? Because that, for security, for scalability, for performance, that would be a big challenge. So that's where you would kind of fall back into this webhook mode, where you're using external policy and or third-party policy engines which are running outside of the API server to be able to do these complex type of checks and operations. And going back to that question on performance, right? So policy and managing a dynamic or a webhook based admission controller versus inline policies. Of course, if you're so anything you run on Kubernetes, like let's say you're running a CNI, if the CNI is down, Kubernetes is not going to work, right? So similarly, if you're running a policy engine like Kyverno, it is a critical component of your control plane. If Kyverno is down, your cluster is not gonna, if you have enforced policies and you want to make sure that nothing gets deployed into your cluster without those policies being enforced, of course your cluster is not going to operate until you bring back Kyverno, right? So it's the same principle, and but there are very well-known ways of managing that. I mean, we all know how to operate Kubernetes workloads. With webhooks, you have to kind of manage, fail open versus fail closed. Fail closed means if the external, like the webhook based controller doesn't respond, you reject or you fail that API request. Fail open means that you're going to allow it, and then later you're going to audit, right? So Kyverno allows this configuration on a very granular basis per policy. So you can decide if a policy should fail open or fail close, and then it will automatically configure the webhooks underneath for you to be able to get the API request from the Kubernetes API server in that manner, right? So if you configure and operate Kyverno properly at scale, again, and treat it like a critical component of your infrastructure, then the only other question is, what is the performance impact of calling an external service? And again, this means that you have to tune Kyverno correctly and manage it correctly. So all of that can be done, and it just and there are several, of course, thousands of users who are doing this with Gatekeeper as well as Kyverno and with other workloads. But where this gets complex is if you start having webhooks for every single check you want to do, and you start deploying hundreds of webhooks, of course that's not going to be manageable. But if you adopt a standard policy engine like Kyverno or Gatekeeper, you're then operating one critical workload, much like your CNI or your other things, and that's quite manageable in most deployments, right? So those are the trade-offs to think about, and decide which one is best. And there is no, what we expect is in production deployments, you're going to be using a mix of both, right? You're going to be using, like, only with Kyverno and Gatekeeper and other things, you can do more complex checks which require lookups, or which are generating resources which Kyverno offers as a unique feature, or which is doing supply chain security, things like that. And then more and more, if Kyverno can program the API server to automatically run checks in the API server where needed, now you have one policy language and one way of managing policies across all of these levels, which is what we want to get to. Just as a quick analogy, like today, the way a lot of people use Kyverno is, if you create a namespace, Kyverno automatically creates a network policy for that namespace. Now, Kyverno does not enforce the network policy, but it generates the network policy and manages the lifecycle of the network policy. So similarly, now when Kyverno can also generate a validating admission policy and manage the lifecycle of the validating admission policy, but it's not going to enforce that check necessarily, because the API server will enforce the check. So it's a very similar progression and evolution of how Kyverno will offer value on top of these Kubernetes constructs itself.
Yes, absolutely, absolutely. That's make perfect sense. I think that one of the analogy that you mentioned is very critically important. Like, let's say if you delete a namespace, and you'd automatically want the network policy should be deleted for that
Right.
namespaces as well. And if we have, I see a Kyverno policies are not maturing enough to do these kind of life cycle management as well, because this is very important for a lot of the scenarios. You specifically some cases you don't want to have policy enabled by default. When the namespace deleted, go delete it out. Otherwise, there's a lot of toil in the NSC. And look how many namespaces exist in the cluster that don't have a member associated with it. Go delete that network policies that don't have, belong to any namespaces. So that's the things is actually quite toil, but that's way how it works. So, as we
So by the way, Kyverno does automatically delete network policies when you delete a namespace, right? So if you set it up to clone from a existing network policy, it will manage the full life cycle for you.
yes, absolutely. And there's an, as we mentioned, like one of the checks, like policies work with supply chain, policy work with monitoring tool, and you have a wonderful debate on this subject, like how this is relevant to call external system to aggregate that data and to use that data propagate to Prometheus or Grafana to look at the dashboards, to let people know that what are the how the policies behave. So it's always been not just policies, but they work with the different systems all together.
Right.
Work with CADA, work with monitoring solution, work with auto scaling solution. Sometimes you need a work with like sometimes we need a policy like if let's say you have a system or the node that is not actually working correctly. When you look at the data in the Prometheus and Grafana, and you will node and you see this node is not actually working very well, do not deploy new pods into it. And
Right.
you can write those policies as well. So remember, policies is a whole new word. It's not just about simple steps. It's a huge word. And I think now people recognize it. That's why we see things like validation, admission policies came up.
Right.
And we have a domain, we have a, I think we discussed this topic like in previous episodes, like do we need PSA or do we need Kyverno, pod
Hmm.
security admission? And a lot of the time, the answer is, do you need both of them alternatively, side by side? Some cases you need pod security admission, and some it's policy engine, and that they live and work side by side as well. So another question, I think, if I look at the one of the feature of validation admission policies, number one, they give you two values as of today, I guess. You can ignore, meaning that when you deploy a policy, what happened to that policy? Do you allow it or do you regret or doesn't allow it. I think we have two values as of today. Ignore means that an error calling the admission policy is ignored, and the API request is allowed to continue. While in the fail state, the API request also be rejected. So another topic I definitely want to check in with you is in validation admission policies, we have a parameter as well.
Right.
This is a policy. We have a parameter source allow a configuration. So these policies actually have a validation admission policy. Now we have a validation admission policy binding, and then we have a param value as well. So, how this relevant? What are the corner cases this actually solve? And do these features exist in Kyverno or other policy engine as well, where you can define a parameter and operator is actually scaling the replicas count? Maybe this param value is actually managed by Kada or Prometheus or Grafana or other external systems who are managing this value. So how you
Right.
look at this feature, because we talk about external system as well.
Hmm. Yeah, so the idea here and the reason for having this parameter value or having a way of looking up these parameters from a separate custom resource, right? So by the way, to get to the parameter value, you need to define either a config map or a custom resource which declares the parameter, and then you leverage that in your policy, right? So there's two or three steps required here to make this work. I think you can, of course, inline that data, which is what it would be simpler and for a lot of simple checks and simple policies. So what we've found is in like 95 or more percent of the cases, you don't require to externalize data parameters and manage data parameters separately, right? And you want, in fact, the whole point of a policy is you want to apply that as one common rule across not just in your cluster, but across all your clusters, right? So if you are parameterizing and customizing that per application or per namespace, you're kind of losing the benefit of having a policy itself. Now,
Yes.
with Kyverno, there's ways to, if you want to exclude certain namespaces, or you want to create exceptions, or you want to create override. Kyverno supports things like customize, so it's very easy to do that and to manage exceptions in an out of band manner, right? So Kyverno does not have like this external parameterization concepts just to keep things simple. And we've never really had the request from our community to say that, okay, that would be a good direction to move in, but certainly we're open to that in the future. Now, when you're designing something for like Kubernetes, of course, you have to maybe accommodate a lot of other use cases, which some of which may be like that 5% use case, but ultimately if you're not able to meet that, then the feature doesn't work for everybody, which is what is very difficult to design things for. At and which is why, again, even if you brought up pod security admission, some of the decisions the Kubernetes team had to make for pod security admission is keeping that in mind, right? So, and then to allow other opinionated systems like Kyverno and others to adapt those features or to extend and improve those features as required. So similarly with this, I think it's a reasonable approach, as long as it's optional, right? And as long as there's easy ways to configure those parameters, externalizing data is always a good thing. But whether it gets used in practice is TBD, right? To see how many would actually end up using external parameters and which use cases does it solve versus just being able to declare that max replicas as a policy, which is a global and a constant instead of something which is a variable.
Yes, absolutely, absolutely. I'm quite naturally true for this question. Like it's very, I think it's in alpha. We have to do a lot of experimental stages
Right.
coming up. Like we do this, do that. But we need, we see a lot of the alpha being removed from the Kubernetes. But
Yeah.
these are trial and test and trying. And alpha means they are actually basically trying out this feature as well. But as of a lot of the, I think we don't have as of requirement of like parameterized policies as of today, but we'll definitely look what is happening in the near future as well. So now we're discussing like I would definitely want Jim, to give us some high-level overview of Kyverno Playground as well. So you
Sure.
can keep sharing your screen and let us know because this is a very new thing. I definitely want to have some conversation, and I think this is the very first time or we're actually showcasing. Plus, I think Kyverno Playground is a work from Frank, our
Right.
policy. And if he's actually watching us today, it's been really appreciated. So over to you now, Jim. You can share your screen.
Yep.
And if you'd like to give some demos and let us know how to use this playground. And
Sure. Yeah. Let me quickly share my screen, and maybe before I show the playground, just want to quickly show also what Kyverno is going to be able to do with validating admission policies, right? So here,
yes.
for example, I have a validating admission policy, which is just like all it's much like what you were showing. It's checking for replicas within
So
a certain.
Jim, are you sharing your screen or we are on a different screen, I guess?
Oh, are you seeing the Visual Studio Code or?
No, I'm seeing a different screen.
Okay, let me try that again. Okay, are you able to see it now?
Yes, Jim, absolutely. Can you
Perfect.
just screen this, just increase the font size, and that's wonderfully good.
Okay, let me do that. All right, so this is an example of a very simple, validating admission policy, very similar to what you showed, right? So it's for a deployment, it's just checking the number of replicas. So what I wanted to show is this new feature that we have been working on, which will be in Kyverno 1.10, 1.11. So if I do, with the Kubernetes kubectl plugin for Kyverno, I can now apply this policy, which is a validating admission policy, into a deployment and then get back a report, a policy report. So minus p is for policy report, and this is being processed by the Kyverno engine, right? So this kind of shows you how these lines will start blurring, where Kyverno is immediately able to process a validating admission policy, create a report for this, and you can run this across your entire cluster, scan your cluster, and do run a validating admission policy, and it will give you back a policy report, which can be displayed in Policy Reporter or Nirmata or any other tool which can process the policy report, right? So that's just one quick flavor of how Kyverno will support validating admission policies. And then additionally, what's also coming in the pipe is like policies where Kyverno, so this is a Kyverno policy, not a validating admission policy, but it's using cell, right? So this is what you were also referring to, is how will Kyverno kind of handle cell? And the idea here is with cell, Kyverno will automatically generate the validating admission policy if it's a simple check which can be run in the API server. If it's a more complex check, then it will run this in the webhook. So as a user, you don't need to care about those type of details. You write your policies, you write your parameters. So there's also an example for your which takes an external parameter. Let me see if I can find that. Um, yeah, so it's maybe it's this one. Yeah, so this is yeah, I don't know if this one is using a parameter, but Kyverno will also be able to handle that as part of a cell declaration. And then, based on that, it will automatically generate your validating admission policy for you and manage the lifecycle, much like today it does with the network policy or other Kubernetes constructs itself, right? So something to keep in mind.
Yes. So, I'm thinking right now here currently is actually if people want to write a policy for the validation
Mhm.
VAP, Kyverno can generate a report for that.
Correct.
Number one. Number two, if you want to use cell language or cell expression inside the Kyverno, you can
Mhm.
do it.
Correct.
Good news number two. Good news number three is like if you want to deploy a policy and use, let's say, valid webhooks or
Mhm.
admission webhooks, You can use WAP, or for the complex system, Kyverno can route the traffic the way they're already working on. It's
Correct.
not for the detail for the developers and the operator to understand whether I'm using WAP or whether I'm using the Kyverno way of working. So
Exactly. So very similar to just like in CNI, a developer who's deploying a workload doesn't care, am I using, Cilium or Calico, right? That's not their, decision. It's just that they want a certain network policy. So similarly, when you're declaring the policy, why care about where it's getting executed? You just want to make sure the policy is getting executed. You have the right reports for it. You have the right way of managing policy exceptions, approvals, things like that, right? So all of that
yes, and
Kyverno will be able to handle that.
yes, so one quick use case. Let's say if somebody write a policy as a WAP
Hmm.
and they publish it into the Kyverno library,
Yeah,
and they put it on the library, then the use case is same. Like you can import that validation WAP policy into the Kyverno. Kyverno number one can apply this policy that actually using WAP, and then also they can give you the reporting, the
exactly,
policy reporting. And plus,
exactly,
if you use it, you can use it, no worries. uh, be- as a cluster admin, we doesn't have to understand if either is using Sal or the Kyverno way of thinking. You're just
right.
deploying in policy and it's working. But for the reporting feature, that is stood out in Kyverno. Number
Yes.
one thing, we don't have any other places we can see the report for the policies as well. Now, but if you have any further on this, you can go it. But I would
Yeah.
like to see, yes, Kyverno Playground.
Yeah, no, absolutely. Right. So this is a pretty complex, something that I was trying out in the playground earlier. It's a complex policy, which is actually a supply chain security policy, right? So the playground, like you mentioned, Frank, has kind of led that effort, and he's the one who also created the policy reporter for Kyverno. So very cool tool which allows you to, define a policy, define a execution context, right? So in this example, I'll go through like what's in the execution context, and then define a resource to apply the policy. So here I have a simple resource, a pod, which is taking a particular image, and then I can apply that, and the playground will execute that operation, and it will then report the results to me to say that this passed or failed. Right. So in this case, it failed because there's something wrong with the like there was and if I look at the details, it's telling me that this particular predicate in my image there was a mismatch. Right. So that's why it failed. So very simple way, and the very cool feature here is you can share the entire playground. So if you are trying to reproduce something and debug something, now you can just share that, and a Kyverno, maintainer or somebody in the community can look at exactly what you're trying to do and kind of give feedback or see that. You can also save this and kind of come back to it. You can load things from, so if you want to kind of start by loading a policy from a website or from other things, that's very easy to do, right? So you could import from file, you could import from a URL. So very slick kind of way. And this policy, just to kind of show how very complex policy can also be executed here. So by the way, there's integrated help, which is another cool feature, right? And because Kyverno uses Open API v3, everything is here available as integrated help. um, but what this is checking is it's making sure that this any image that you're running is signed by the appropriate, in this case, it's using six-door cosign and the keyless mode, and then it's checking different attestations in here, right? So let's say, for example, I make this, just as a test, and I run this again. Previously, it failed. What I would expect now is this policy to pass because my timestamp matches, right? It's within that range that I configured. Previously, it was just 3 days. Now I made it 300 days, so it will pass, right? So very, very cool feature. Excited to have this. And where we see this, I mean, Kyverno policies, you could do all of this in Visual Studio Code, or you could do this with the CLI. But this gives you a nice, concise way, workspace to do that, share that, and communicate across a team, which is where we see the playground resonating quite a bit.
Yes, absolutely. And one more thing, I think the playground can be used. I created a dedicated spot for that. If you want to test policies for Kyverno
Yeah,
before applying them onto the production, go to the Kyverno Playground. You can write those or you can execute those before deploying them into the production.
that's
That
right.
is another cool feature of it as well. But now Jim is here. Jim is actually telling us some of the use cases for writing the policy, for test casing the policy. I've been the big fan of the unit testing as a developer, and for the operator, I think you are always the big fan to test things before deploying to the production. So some of the test cases for Kyverno, what do you see?
Yeah. So the whole idea is to, of course, treat policy as code, right? So just like with code, you would do unit tests, you would apply those unit tests in your CI/CD pipelines. So similarly with Kyverno, the CLI has a test command, and the playground adopts a similar kind of logic where you can now write your test cases, and you can in that test case you can say which ones should pass, fail, what should be allowed, what should not be allowed, right? So that is very much possible now with the playground, and you can even write your success and your failure cases and then check each one of those in terms of what should be handled. So you could test for those in the playground itself with different context values. So the context is where you would put in your variables, which otherwise it would be looking up from the cluster, and then it would execute and show you the results.
And like another, like I think another use case it would talk about, like let's say if you are working with external system, let's say Kada or Prometheus,
Hmm.
or are you actually collecting the data, or are you giving back data to the external system? So are these test cases for along the, let's say if I want to push data for the Prometheus to aggregate it and give a cluster admin to look and see how things work while we enforcing policies. Could we write test cases for those as well?
It's possible, but in again, if you're running these tests as a unit test, you would want to limit the interactions with external systems, right? If you're running this as a integration test or as a system test, of course you can do that, as long as you make sure the external systems are available. You can now call, you can either push things or pull things from external systems as required.
Yes, absolutely, absolutely. And you all see how the output look like for testing the policies. There is a wonderful blog that's newly came up. I have taken the screenshot for that blog. It's from the is from Ushi Gupta and on the news
Right.
stat. I will link to that on the YouTube channel so you can view it. So basically, this thing is I most loved by the community because everybody want to test because remember when you apply policies and if you accidentally deploy policies those are faulty and developer doesn't able to deploy their workload on top of them, then it's creating a chaos within the organization
Right.
and you keep battling with either other. Why am actually my work is not actually been uploaded? So this is the thing give us a more control of how things work. I think this should be explorable. If you have time, go explore that as well. And with that in mind, I think we covered so much of it. But the final question to wrap up the topic: Kyverno plus GitOps.
Hmm. Yeah, so uh, I think again, Kyverno, just like with any other system for Kubernetes, of course, GitOps, as it becomes more and more popular, we see a lot of deployments, using Kyverno and GitOps. So it works very well with Argo CD as well as Flux. In fact, with Flux, one of the things, which is very cool, which I'm not sure if folks have tried out. So Flux uses server-side apply to be able to check even for mutations, right? So it will handle things like if Kyverno replaces the image digest, Flux automatically handles that, and that's something which is extremely powerful. With Argo CD, it is possible to also manage that, but you have to kind of take some extra steps in how you configure Argo CD to manage that. But yeah, it's certainly very much very possible, and we see the combination of GitOps and policy being extremely powerful for Kubernetes everywhere.
Yes, absolutely, absolutely. And thank you very much once again, Jim. Every time I come up with a new topic in the policy landscape, I will interrupt Jim, and he's very kind enough to spend time with us, sharing his knowledge. I believe this is a most important debate in policy world right now. If you happen to be in this world for a very long time, this is the most important debate right now, because some of the people think this is work like similar, like the CNI, CRI, CSI. We see a standard in the Kubernetes space, and Kubernetes adopts standard and ask vendors to implement those standard and do the work that you're already doing. But the way what I learned today is expiring for me. If you are using validation admission policies, and if you are a Kyverno user, you have so many good news. Number one, you can actually apply those WAP policies no matter what you actually, it doesn't matter for the Kyverno. You apply those, Kyverno also generate a report for that. How awesome is this? You can apply the WAP policy and the report is generated. And we keep stressing the gem, I think, when Frank is working on this project. Why this is important? This is important because you give this report to the external system like Prometheus and Grafana. And the cluster admin can look at the report to see how the cluster is responding before the policies get applied and after the policies get applied. Everybody wants that data. So if you are applying WAP and WAP doesn't give you policy reporting, use WAP for your needs and for the policies for the Kyverno. Number two, if you're writing policies in WAP or in a cell, do it. Doesn't matter for a Kyber if you're using Kyverno. You just deploy everything as a platform operator. You don't need to worry about is it a WAP or is it a Kyverno. You just deploy it. It works under the hood. And number three, Kyverno wonderfully integrate very well with all these PSA and all these kind of tools because it's work with the notion. Like I really like this, I think, mentality that the Jim spoke today. Forget about the inner working of the policy engines, do the work that you're already doing. Like if you're using CNIs like Cilium or Calico, you don't know how the Cilium or Calico work under the hood. You just deploy some command, networking is being set up, and your job is quite easy. So that is same revolution is happening in the policy world. And thanks to the Jim team who are working on these features as well. So before you, I let you go some final point and plus some final tips on what's new in the Kyverno 1.11 and what's new is actually coming up because I haven't talked about multi-tenancy. That is another big area where Kyverno fits very well. We have
Right.
there are so many other places and policy, remember, is a huge landscape. It's look narrower, but when you try to implement the landscape wider, so people like to know what's next and what most exciting in Kyverno 1.11. And Jim already did a presentation on CNCF YouTube channel on this topic. Do not miss it. So many awesome news for you if you are actually Kyverno user. So final thoughts.
Yeah, so just to quickly wrap up, Kyverno 1.10 is being released, so it's going GA, and that is our latest official release. 1.11 is actually work in progress, which will be about a couple of months away in terms of the first beta or release candidate, but that's something we're actively working on as well. So in 1.10, the major feature is for scalability. We have kind of decoupled a lot of the Kyverno controllers. The webhook is now separated from the background controllers. There's also support for notary and notation, which is a new supply chain security format. So that's a very exciting development in 1.10. And then there's, pretty much a major rehaul of the generate and mutate functioner for more complex use cases for generate mutate. Lots of other improvements. There's also like servers, external service extensions, which you can now do in Kyverno, which is so Kyverno can be pluggable. You can write, so you can even have a Kyverno policy call a Golang server and incorporate that into your policy check. So all of this is in 1.10. With 1.11, the major focus is going to be on, on validating admission policy support, as well as a few other features. We had introduced a first version of cleanup policies. So there's a lot more feedback and things we've received on that. So cleanup policies will get a lot of major features in 1.11 and few other things that we're kind of putting into our pipeline for that.
Yes, absolutely, absolutely. I think there's a lot. Like, I think we started with the Kyverno, I think way back 2 years ago. But as of today, if we keep out talking about Kyverno for the last next 5 hours, that content it will never stop because there's so much happening. The community grow. I think this Kyverno is one of those projects. We have exponential, one of the fastest growers growing project in the CNCF, and that see the need of how things evolve in the ecosystem. I think in future we definitely want to interact with you with the community, how the Kyverno work with the cluster operator level. We talk about developer in the past, but for those people who are upgrading the Kubernetes cluster, how Kyverno can shine in. Like, remember, if you can deploy, let's say, if you can restrict pods to not deployed on the certain nodes, or not on the
Hmm.
certain clusters, or not on the geography or the regions. You cannot deploy cluster on that region or on this specific region. The policy is a whole new world. Is a huge landscape now becoming. Think about some of the things, and that the policy solves is actually wonderful. So next, before I let you go, there are some learning resources for you. Number one, you have to go check that out, Kubernetes docs, and look at the things how validation admission policy works. Then, if you understand this properly, go to the Kyverno Playground and start playing with validation admission policies and Kyverno in general. And we have a wonderful debate on previous topic like PSP, how to migrate PSP to the Kyverno, how to migrate from the PSA, and how PSA and Kyverno work. And there is a workshop we did, I think, 2 years back with Shooting and Jim, that our first interaction, how Kyverno works by hand. This is also available. And also, how do you actually use admission controller? There's a developer guy who had wrote a wonderful article. Policy reporter from Frank is one of the most advanced feature in Kyverno we don't have in many other places in the policy world. Go check that out. Frank is a great community member, and his contribution are so awesome for the community in the Kyverno. There is another practical guide. I think this is wrote by some of the Cubescape community around how to actually use validation admission policies as a practical example. And GitOps with Kyverno is a wonderful topic. We have done a podcast with Jim and Jesse Suan, where we talk about how these two different tools work together to achieve a wonderful results of your time. But it's been an incredible way. I'm very, very fascinating to see how the community evolved with the Kyverno, and there is always so much content to cover about. And thank you for the wonderful comment, Mishra. I hope you like the conversation. It's very important for everyone to understand how the next pieces work. But once again, thank you very much, Jim, for a tremendous conversation, for the wonderful visionary side. And you actually let us a wonderful news like Kyverno seamlessly work with the external systems, the new adoption. And if you are the Kyverno user, you feel proud about the technology you are using. So thank you very much, Jim. We will connect again in future. Have a wonderful day, everyone. Stay safe, stay healthy. Bye bye, everyone.